Well, howdy there, Internet people. It's Bo again, and welcome to the Roads with Bo. Today is going to be a little bit different. We are going to delve into how to adapt your surroundings. We talk about preparedness a lot on the channel, and one of the things that we talk about is how to improvise, how to alter your surroundings. This is one of those things that's it's incredibly valuable as a skill during a bad situation. But once you start to look at the world through those eyes, you start to see that your situation is a little bit easier to change in other ways. It helps you view the world as components to a an outcome you want to achieve rather than everything being an obstacle. Um, so today we are going to talk about power and how to achieve it. We're going to talk about batteries. Um, we're going to, of course, talk about the ones you learned about in school: a lemon, a potato. We'll even make one out of mud. Um, but we'll also talk about some that are a little bit more advanced, and these will be things that you can put together with the stuff around you, with the components that are available to you, and then from there we will continue a series on and learn about how to apply some of it. So, to start with, we have an off the shelf science project kit here. And we're going to use this to form the basis of what we're doing. And it functions by creating an Enviro battery that uses zinc and copper plates in a watery electrolyte solution. The first version we're going to do here is one using a lemon. So, you start with your lemon and then you take it and you cut it in half. Now you're going to add the components from the kit. You're going to take one zinc and one copper plate and stick it into each half of the lemon. The zinc acts as your negative electrode and the copper acts as your positive. Connect one zinc and one copper plate from each half with the white wire. Then connect the red and black wires from the watch to the proper electrodes. Black is universally recognized as negative, making the red the positive. And here you can see the watch is now powered by your lemon battery. The electrolytes in the water interact with the metals, creating a chemical reaction. This reaction breaks down the metals, causing them to release electrons. The reaction happens quicker with the zinc plate, causing a flow of electrons from the zinc to the copper plate. This flow of electrons creates a small electric current. Although the current is relatively weak, it is still able to power a tiny LED light bulb, a small digital wristwatch, or a small circuit like a sound chip. Now, your medium for this could be nearly anything from around the house or the yard. You can use a potato, you could use a piece of fruit, you could use a couple of potted plants. It really doesn't matter as long as you're completing the circuit. All right, let me jump in and kind of interrupt for a second. I know right now some of y'all are looking at this like, hey, I did this in middle school or I did this in high school, maybe even elementary school. And for a lot of the beginning of this series, that's going to be true. But this is one of those things where everybody needs to be on the same page, have the same foundational elements. As we move forward, things will get more interesting, a little bit more complex, a little bit more obscure as far as how some of this stuff works, but it all builds on each other. I promise you, you will see this material again. So this next one is going to require you to create an electrolyte solution by dissolving some table salt into water. Here's everything you'll need for the next project. Take a quick look. Start by sanding the rims of your cans to remove the coating and reveal the aluminum beneath. Attach your screw connectors to the outside of the can. Now it's time to sharpen the pencils. And when you do that, you're going to have to sharpen both ends of the pencils. Add your saltwater solution to the cans, filling them about 3/4 of the way. Now you're going to connect your pencil holders. Then you're going to place the pencils into the solution and begin connecting your wires. The positive, red wire, connects to one of the pencil tips above the rim of the can, while the negative, that's the black wire, connects to the screw on the adjacent can. Finish by connecting the white wire from the other pencil tip to the screw on the adjacent can. This completes the circuit. By introducing the graphite within the pencils to the solution, a chemical reaction occurs. This reaction causes some of the tiny water molecules to split into ion particles. Hydroxide ions from this split form another reaction with the aluminum inside the can, creating a substance known as aluminum hydroxide. This releases electrons that create the electric current used to power this calculator. This is also sometimes called an aluminum air battery. Another battery that we can make up real quick is one that uses pennies, vinegar, table salt, and cardboard. Here are the contents of the off-the-shelf kit that we bought. All you need from home are a few paper towels and some distilled white vinegar and table salt. Start by punching out 17 coin-sized cardboard pieces. Then count out 17 copper and 17 zinc coins. These would be the pennies if you were doing this not using a kit. If you're using pennies, use post-1982 pennies because they are copper over zinc. Here is a cool little casing that comes with this kit that we're going to use to build the battery. Go ahead and mix up your solution. It's going to be 1/4 cup vinegar and 1 tablespoon of table salt. Soak the cardboard pieces for 1 to 2 minutes. Pull the cardboard out of the solution and blot dry with a paper towel. You want the cardboard damp, not dripping wet. Excess liquid will short out the current. Start your first stack of coins. In order, it's going to be copper, zinc, cardboard. Start with the copper at the positive end of the battery case. Repeat the stack 16 more times in the same order until you reach the last stack. The final stack will end on the zinc coin, not the cardboard. Then you can close up the battery casing. All that's left is to grab the flashlight. Then you're going to insert the battery and replace the end cap. Test it out to make sure that it powers on. Then test, test, test. Looks like you have a working flashlight. Okay, so that's a little bit more information, a little more context, and having the right information will make all the difference. This series will be around. There will be more coming. And as we do it, you will learn how to do some other stuff and alter your environment in other ways.